Hello! So in this video we're going to talk about adding and subtracting polynomials. The main idea is to combine like terms. So I'm going to look at all of this entire polynomial. I'm going to look at each term and figure out which ones are the like terms and combine those first. I noticed that the 4 and the 4 and the negative 4 and the 4 have the same variable term, the same degree, the same exponent. Those are like terms. And so we're going to combine those. I'm going to underline them twice, just kind of highlight those. So I'll combine those using the sign that's directly in front of them. So I've got positive 4n to the fourth, and then minus 4n to the fourth, and that's going to be, I'm just going to write these here, 4n to the fourth, minus 4n to the fourth, bringing down the signs that are with them. I'm looking through the rest of the problem, and I see there's just this 1 plus 3n squared. There's no other n squared terms in the problem, so I'll write that down. And then I have just this constant all by itself, no other like terms like it, so I'm going to write it down at the end, keeping the sign of the term. Now I can combine everything that's right next to each other and looks like each other. So 4 minus 4, I just look at the coefficients. That 4 minus this 4 is 0, so those cancel each other out. And what I'm left with here is just 3n squared minus 5. And that is the simplified answer to this polynomial. The next problem we're going to look at involves some grouped polynomials. I have two binomials, meaning there's two terms in each. What I'm going to do is make sure that I keep the same sign in every term after this, because I'm adding these together. So there's no sign changes that are going to occur when I drop the parentheses. There's no need for parentheses in this problem anymore. So I'm going to rewrite this as 4m to the fourth minus 3m plus, and this would be actually negative m to the fourth plus 4m. I have to keep this sign to make sure it stays negative, the original problem that I had. So now I'm going to find my like terms. So I see I have 4m to the fourth and then a negative m to the fourth right here. Those are like terms and I can combine them. I'm going to go ahead and combine them right now. So I take the coefficient, which is 4, and the coefficient here, which is a negative 1, and I add those. 4 plus negative 1 gives me 3. So I'm going to write this term as 3m to the fourth. The next one is negative 3m. That is a like term with a positive 4m here. I look at the coefficients and I say, well, there's negative 3 plus 4 gives me positive 1. So that's positive 1m. And usually we don't ever have to write a coefficient of 1. It's understood that there's always a 1 in front. So the answer to the simplified expression is 3m to the fourth plus m. Next we'll look at some subtraction. I'm going to subtract this entire binomial from the first binomial. The way we do that is we can keep the first binomial as is, but when I subtract the second binomial, I need to make sure I'm doing the opposite. And that's what subtraction means. It means adding the opposite. So one way I can show that is by rewriting the problem as negative 3 plus 3x to the fourth, then minus negative 2 minus positive 4x to the fourth. Remembering that every term inside the binomial is going to be subtracted from the first terms. So one thing I can do is simplify this. I know that subtracting a negative, this is like adding the opposite. So it turns into plus 2. And then subtracting 4x to the fourth, I don't need the parentheses anymore. I'm just going to subtract it. Once all of my signs are simplified, now I can combine like terms. Looks like I have a 3x to the fourth here and a 3x to the fourth here. Those are like terms because they have the same variable and the same exponent. So I do positive 3 minus 4. I should underline the negative symbol in the front. That goes with this 4x to the fourth. So 3 minus 4 gives me the opposite of x to the fourth. And then I have negative 3 and positive 2. I'm just going to simply add those. Negative 3 plus 2 gives me negative 1. So the simplified answer is x to the negative 4, opposite of x to the fourth minus 1. All right, last problem we're going to look at in this video, just kind of bringing everything together, subtracting, and then also making a larger polynomial at the end. First thing I'm looking at is the first term I never have to use parentheses with. It's just grouping the first expression. So I'm going to write this as 4x squared minus 3x to the fourth. What I need to be careful for next is making sure I'm subtracting every term that comes afterwards. So this negative symbol, this subtraction symbol, is going to do the opposite to every term that comes in the second polynomial. The opposite of negative 5x squared is going to be positive 5x squared. And then the opposite of negative 2x to the fourth is going to be positive 2x to the fourth. The opposite of x cubed is going to be minus x cubed. Once I've distributed or turned the opposite of every term in the second polynomial, now I am ready to combine like terms. Looks like I have negative 3x to the fourth and a positive 2x to the fourth. They have the same variable, the same exponent. So I can add those, and that gives me a negative x to the fourth. Next, I see that there is the next lowest exponent is x to the negative 3. And there's no other x to the positive 3. There's no other x to the positive 3 terms. So I'll write down minus x cubed. And next I have a positive 4x squared and then a positive 5x squared. Those can be combined, same variable, same exponent. They're both positive, so it's plus 9x squared. I've accounted for all of the terms in the polynomial, and here's my answer.